Okay, 3.4 is more story problem type questions here. So it says one of the most common applications of calculus is solving optimization problems. That's what this section is on. Okay, so what optimization problems are, you need to find the max or min value for a particular quantity in the problem. So to do this, you need a primary equation and a secondary. So we're going to find a primary equation and a secondary equation almost every time, okay? So primary equation gives a formula for the quantity to be optimized, and secondary states a relationship between the variables, which they kind of tell you in the problem. Another thing that you want to look at is a feasible domain. You have to just make sure that your answer makes sense for the problem for these. Sometimes maybe negatives don't make sense, because here it says the product of two positive numbers. So what would be my feasible domain there? Not all reals, but 0 to infinity, right? Because it doesn't make sense to even include 0 or any of the negatives. So let's start here with our feasible domain. So our feasible domain, we'll say, is from 0 to infinity, and 0 doesn't make sense because it says positive numbers. And then let's start writing equations for what they're giving me. So they say the product of two positive numbers. So let's call x my first number, and y will be my second number. What does it mean, product? Multiplication. So what do I know is equal to 72? X times y, right? Because my x and y, if I multiply those two numbers together, I get 72. So this is my secondary equation here, okay? It's not what I'm trying to maximize or minimize, but it's going to help me solve the problem. Now your primary equation is what you're trying to maximize or minimize. So am I trying to maximize or minimize this one? Minimize. So I usually just write that here so I don't forget that I'm trying to find the min. And I'm trying to minimize the sum, right? So I'm going to write it as S equals, because it's a sum. So yep, it says minimize the sum of the second number, which is y, and means what? If it's a sum, I'm adding, and then twice the first number would be 2x, so it would be y plus 2x. Or 2x plus y, it doesn't matter. So questions on that at all? Okay, now this is what I'm trying to minimize, right? Think about how we've been doing our calc problems to find the minimum. We do what? Get what equal to 0? The derivative. So we'll have to take the derivative, set it equal to 0, find the critical numbers. Then we can either use the number line or the second derivative test to see if it's a min, right? So to take the derivative, I don't like having more variables in here. So I don't want to have this y in here. What can I replace the y with? 72 over x, right? That's what the secondary equation is used for, plugging it into there. So I know x times y is 72, so I know y is 72 over x. And then we're going to go ahead and plug that into the primary equation. So you always want to use your secondary to plug into there. So now don't I have my sum just in terms of x? And it's 72 over x plus 2x. Or you can write that as 72x to the negative first plus 2x. And we said we had to do what with that? Derivative. So what's the derivative? Negative 72x to the negative second plus 2. And now I'm trying to set this equal to 0. So let's just set it equal to 0 the way it is. So this is negative 72 over x squared, right? Plus 2 equals 0. then I'm just going to move this to the other side. You can solve it different ways. You should get the same answer. But if I add this to the other side, don't I have 2 equals 72 over x squared? And then what do? Multiply the x squared, so I get 2x squared equals 72. So x squared is, which is 36, and so my x is plus or minus 6. And then thinking back to my domain, yeah, it's only feasible to use the positives here, right? Because it was positive numbers. So really I'm just dealing with x equals 6. Okay. Any questions on that? And now I have to determine, I want to show that that's a minimum, right? That was kind of the thing here. So let's use the second derivative test because it's kind of easier, I think, in this case. So second derivative of this is 144x to the negative third, and that's 0, right? And then what do I do with the second derivative to find if this is a max or a min? I plug it in. So I'm going to plug 6 in. And you could do the number line thing too if you like that better. So if I plug 6 in here, is it going to be positive or negative? It doesn't even matter what the value is. This is 144 over x cubed, so it's positive, right? So I've got positive. So if it's positive, I'm sorry, I have a couple eyes there, but if it's positive, that means it's concave up. If it's concave up, it's going to have a minimum. So this is going to have a relative min at x equals 6. So you have to show that it's a min. Now we have to answer the question, which a lot of people kind of forget to do here. So going back up, minimize the sum of the second number and twice the first. So I actually want to find what the sum is at the end. So if I know my x is 6, what's my y going to equal? 72 over 6, which gives me 12. And then I want to find the sum. So the sum was y plus 2x. So that's going to be 12 plus 12. So my minimum sum would be 24 when x equals 6 and y equals 12. Questions on that? Yep, these ones require a little work. Okay, what we're doing for this one, it says find the points on this graph, so I graphed it so you could kind of get this visual of what's going on, that are closest to 0, 3. So isn't 0, 3 right here? Okay, is it necessarily the closest if I go straight up? No, it's probably closer if I take some sort of an angle here, right? It's definitely not going to be closest like down here, but it's probably going to be somewhere, you know, this direction. And wouldn't it be the same on this side? Yeah, so it's feasible here to have positive x's and negative x's, isn't it? So if you want to kind of sketch that, we're trying to find, what are we trying to do with this distance from here to here? If I want it to be closest. Minimize it, right? I want that distance to be as short as possible. So let's just maybe write that here. Minimize the distance from 0, 3 to a point on this y equals 4 minus x squared. Do you see how this is already a y equals? So this is my secondary equation already given to me. And my primary equation is what I'm trying to minimize. So my distance is going to be my primary equation. Okay. Feasible domain here, we don't really restrict our x's. Obviously, our x's are probably between -2 and 2, right? So if you wanted to put that, you can, but really we can have positives and negatives. So feasible domain, I'm not going to really restrict it in this case. So I'm just going to say negative infinity to infinity. Okay, so let's come up with our primary equation. So if I'm trying to minimize, let's come up with our distance. Do you guys remember the distance formula? So let's say here, minimize the distance from 0, 3 to a point on this, and let's just call that point x comma y. So this will just be a generic point to start with. How do I find distance? Big square root. Yep, x minus, so changing x to be x minus. Right, so I'm taking my x minus my 0, right? Plus, what do I still need with this though? Squared. Plus 3 squared. Now this has too many variables in it. I don't like those extra variables, so I'm going to replace the y with 4 minus x squared, because that's my secondary equation there. Oh man. We're going to see if it'll keep going here. Okay, so I've got my distance formula, and I plug in the y minus, what was it? Oh, sorry, 4 minus x squared. Okay, so my distance formula I'm trying to minimize here. We'll get there. So just pick up where the notes left off there. Would be square root of, and the x minus 0 is just going to be x squared. And then I've got that 4 minus x squared is my y1, and then minus, what was it? Y minus 3, right? Squared. Yep, and then I'm just going to combine these together. So the 4 minus 3 just gives me 1. So this just turns into an x squared plus 1 minus x squared squared. Does that look right? And then can I square this out? I might as well, right? I'll make it a little bit easier, I think. So if I do 1 minus x squared times itself, I get 1 minus 2x squared, and then plus x to the 4th. Does that look right? And that's added to this x squared, isn't it? So what do I end up with total? Let's put them in descending order. X to the 4th minus x squared plus 1. Does that look good? Oh, I just erased it. The x to the 4th is just here. 1x squared minus 2x squared will give me negative 1x squared. Okay, you got it there? Okay. Okay, so we're back to here. So this is my primary equation, right? Let's write this. So this is my distance in terms of just x. So we'll write that as x to the 4th minus x squared plus 1 to the half power. And then what do I have to do with that? Derivative. So let's do our derivative. Pull the 1/2 down, leave the inside alone. And it's raised to the negative half. And then multiply by the derivative of the inside. 4x cubed minus 2x. Questions there? Now, I don't know if you guys see this or not, but can I pull a 2 out of both of these? So if I factored a 2 out, wouldn't it cancel with this half? Okay, so let's, I guess, yeah, we can pull a 2x out. So that's going to be in the numerator, right? What would be left if I took the 2x out? 2x squared minus 1. And then this 2 is in the denominator, so that's where it'll cancel. And if you saw that earlier, you could have canceled it a little earlier. And then I've got that square root in the denominator because it's a negative half. Then what do I do with the derivative? Set it to 0. So my d prime is equal to 0 when my numerator is 0. And this equals 0 either when this is 0, so I have x is 0, or when this is 0, right? So wouldn't if this is 0, wouldn't my 2x squared equal 1? And then divide by 2, so my x squared equals a half, and then I square root it, so my x is plus or minus, what's square root of 1? 1, what's square root of 2? Square root of 2. Okay, so these are my critical pieces. The denominator is never going to equal 0, okay? So let's just write a little note there. D prime is never undefined. And then what do I do with my critical pieces? You can either do the second derivative test, which the derivative's kind of terrible, right? So instead of doing the second derivative test here, I'll probably do the number line. I usually use the second derivative test when the derivative's like, you know, kind of nice. Yeah, polynomials are really nice for that. And then I'm plugging into the derivative, right? So if I plug in something huge into the derivative, the denominator is always going to be positive, isn't it? Because it's a square root, it's got to be. So I'm just worried about the numerator. So if I plug in something huge, I get a positive. If I plug in something really huge negative, wouldn't it be negative? Right? And then in here, 1 over square root of 2, if I plug in something that's really close to 0 but positive, this would be positive, and this here would be negative. So this would be a negative. And then this is going to be the opposite. So that means that D is decreasing, then increasing, then decreasing, then increasing. And what am I trying to do, max or min this? Min. So the min's going to be here and here, right? Where it changes from decreasing to increasing. Which makes sense that it's the x values on both sides, right? Because we said the distance would be here, and it should be the same on this side because of the symmetry. And then how do I find the y values that go with that? Plug it into your original. I'm just going to save us a little time and just do that. Okay, so you get 1 over square root of 2 is the positive, goes with 7 halves. What do you think is going to be true about the y value on the opposite side? No, try again. Look at the graph. Wouldn't it be the same y value if it's here and here? Yeah, so it's going to be 7 halves again. And that's what I was asking for. So questions on that?